Hey Math 1B, I've got a new video for you. We're just extending 4.4 one step further, and I hope you guys find this to be super simple if 4.4 made a lot of sense to you. So, what we're doing now is we're trying to figure out what happens when we put exponents on the outside of a group of parentheses when there's an entire polynomial inside. Well, if you see a little 2 up here, it means you're multiplying the thing in parentheses by itself twice. So you rewrite x minus 3 times x minus 3. Okay, it's a problem from yesterday now. How do we solve multiplication of polynomials? Well, everybody in the purple group is going to be multiplied by everybody in the red group. So I'm going to rewrite purple x times red x minus 3. Purple negative 3 times red x minus 3. So nothing really all that new. I'm just I'm showing you guys what we're supposed to do if you see an exponent on the outside of parentheses. So then you take x times x to get x squared. You take x times negative 3 to get minus 3x. Minus 3 times x is minus 3x. And then just make sure you don't fall apart on this very last step. A negative times a negative is a positive 9. Final move is combine the like terms that you can. A negative 3 minus 3 would be minus 6x. And then these two just kind of fall in line. And there's your answer. Let's try again here. By the way, I'm going to switch this to a plus. I'll make sure I switch it on the document before I post it on YouTube. So 6h plus 5 is going to be rewritten twice. Yeah. And really I should put one in red and one in black just so we're absolutely certain that, hey, the black 6h is going to be multiplied by the red 6h plus 5. The black 5 is going to be multiplied by the red 6h plus 5. Yeah, again, nothing all that different from what we saw yesterday. Multiply everybody out. 6 times 6 is 36. H times h is h squared. 6 times 5 is going to be 30 with an h attached to it. And this is going to be the exact same thing. 5 times 6h is the same as 6h times 5. It's plus 30h. 5 times 5 is 25. The middles combine to give us 60h. So not only does this show us how we can expand the polynomials, but it should also show you that you cannot do this shortcut. 6h plus 5 squared is not 36h squared plus 25. That's oftentimes what students try to do. They're like, hey, there's a little 2 on the outside. Didn't we distribute that to all the parts on the inside? We did that when it was nothing but multiplication. So you got to take that fake shortcut and toss it out of your brain. So expand the polynomial like you did before. You just got to do a rewrite if you see an exponent. Don't try any bogus shortcuts. Okay, what else we got here? Nothing seems to be amiss here. I've got this one. And, oh, I see. Okay, so it looks like we got twins. Good twin, bad twin. Now, how does that change our multiplication of this? It doesn't. 4x times 4x plus 3y. Negative 3y times 4x plus 3y. And then it just gives us a bit of a review of how you're supposed to multiply different variables to one another. 4x times 4x is 16x squared. 4x times 3y is going to be plus 12xy. Now, we talked about this on the previous video. If it's minus 12, yx is the same as xy. So you can just rewrite this as xy so that we can combine with the other one. And then negative 3y times positive 3y would be minus 9y squared. So when we combine the two middle terms, because they're like terms, 12 minus 12 is 0. Okay? 0xy is 0. So whenever it's just 0, you can cut the whole thing out, and you're left with two terms in the polynomial. Interesting. So if we had a good twin, bad twin situation and the middles canceled out here, my question to you is, are we going to get the middles canceled out here since it's the identical situation? Try it on your own and see if you guys can come up with the answer. All right, let's see if you guys did it right. Write the first one in a one color, second one in another color. We can separate by 2a is going to be multiplied by 2a plus 9. Negative 9 is also going to be multiplied by 2a plus 9. Distributing gives us 4a squared plus 18a minus 18a. The middles do cancel, and you got minus 81. So interestingly, we've got a pattern here. When it's good twin, bad twin, the middles are always going to cancel out. And you're left with the first one times itself, the last one times itself, with a minus in between. All right. Woot for patterns. Last one. Ooh. We've got exponents at the very beginning. How is that going to change the process? It's not going to change the process. We're still going to identify this as, in this case, the green group. And this one is the purple group. How do we expand polynomials? We're going to take the green times everybody in the purple. We're going to take the other green times everybody in purple. So x squared times x squared is going to be x to the fourth power. Remember, when you multiply powers of the same bases, you add the exponents. This one's going to be a minus 5 x squared y squared. Over here, this is going to be a plus 5 y squared x squared, which we can flip around to make it x squared y squared. And then you take 5y squared times negative 5y squared, you get negative 25y to the fourth power. All right, you've got identical middle terms that are one's a minus and one's a plus. They cancel, which makes sense. It was good twin, bad twin from the get-go. And then you can't combine these two, so you're just going to have to write them side by side. All right, guys, that's all I got. Hopefully you made sense of this as it compares to yesterday's work. And yeah, get to it. Thanks for watching.